Hey everybody, I'm just going to do a little video going over the DESMOS activities that we did. So this is the one that's looking at the properties of trig functions, where we will look at the amplitude, period, phase shifts, and vertical shifts. So as we go through, so here we're just kind of noticing the difference when I have different values in my equation from the base function. So the one I just clicked on here is sine of x, which is what we would call the base function. Okay, so then if I hit 2, right click on this one, you look and you're like, generally, like what I've done is like this has been stretched vertically, right? And I click on 3 sine x, that has been stretched vertically, right? So obviously if I put something like this in, a sine x, added a slider, let me show you this, right? The a value is going to change the shape of it, right? So these are stretched, right? It can be compressed, it can be reflected, all that kind of stuff, okay? So we go to the next. Now what's the amplitude? So generally, if you remember from like when we had regular trig functions here, or sorry, not trig functions, just regular functions, right? Like if I had 2x squared or 2 root x or 2 x cubed, right? Like this, the 2 here, right, was the a value, right? A equals 2. So the same thing happens for the trig functions, right? So if I look at my the number in front of sine x, this is just 1, this one is 2, this one is 3. So hopefully that was relatively easy, okay? Here, same deal, we're going to click on this, right? So this is 3 sine x, and then obviously when you look at the next one, like this one is negative, so it should reflect over the x-axis. Okay, so just if I were to go over that again here, right, if I have, say, this graph, right here, a is -3, so my amplitude is still 3, like it's positive, but this one is reflected over the x-axis. Okay, so that's why when we look at the graph here, if I click on it, right, it's just the reflection of the blue, right? Okay. Describe how the two graphs have changed. Generally, we would say what I put over here, right? That, you know, the blue one and the purple, right? The purple is just a reflection over the x-axis. The amplitudes are the same, right? If you look at the distance from here to here is the same from here to here, right? Okay, also a cool thing, if you didn't know, like if you click on the graph, then you'll see like the actual coordinates, which will help you with like phase shifts and stuff. All right, are the amplitudes the same for both graphs? Well, I just said that, right? Where if I have, if we have y equals 3 sine of x, and then another equation, y is -3 sine of x, right? These have the same amplitude. Okay, this one is reflected over the x, but their amplitudes are the same. Okay. Period, remember the period is just a horizontal length of one cycle. So again, here if you're unsure what scale, like you can just click on it, right? And say, okay, like, and notice how I also mentioned about the key points. See how it brings up the key points, 90, 180, 270, 360. So one complete revolution, is for this one 360. Okay. This one, same deal. I can look and see what's happening here. This one looks like it's a little squished. So the period here is 180, right? One revolution, right? Starting from here is 180. Now, can I look at anywhere? Yeah. You could go from here to here and then say, well, what's the gap between negative 135 and 45? Well, that also is 180 degrees. Okay, and then this one is getting smaller. So if you click on it, you'll be able to see that, holy moly, this one is a period of 90. All right. So if you look, where's 360? 360 is right here. So in this example, for this particular equation, like how many waves are there in 360 degrees? Well, there's 1, 2, 3, 4. Okay. Now, by analyzing the graph, how do we determine the period? So here, if it's difficult to notice the pattern, we can say, okay, well, if I look at right, if I have sine of x, sine of 2x, right? Sine of x has a period of 360. We know that. This one, if you looked at the graph, this is a horizontal compression by 2. So if I take the period of sine of x and divide it by 2, right, I get the period of sine 2x. So here for the unknown values is sine 6x. Well, what would I do? I would say, okay, well, if I have sine of 6x, right, the period is just going to be 360 divided by 6. Okay? And then I had sine of 8x, and I would do the same thing, right? Period is 360 divided by 8. Okay? So if I go back to the screen here, sorry, I was just quiet. I thought I heard my kids freaking out. So yeah, so this one was 60, and then this one is 45. Okay. So again, hopefully you recognize that this is like the general, the simple mathematical process here is just taking 360 and dividing it by whatever like the d value is. Okay, and where do I get? And remember this 360 here, right? This comes from the base graph that the original sine of x has a cycle of 360 degrees, or a period of 360. Okay, so then this one just dealt with phase shifts. So again, here I have sine of x, here x plus 90. So when I see it, right, this has just moved 90 degrees in the negative direction. Okay, so this is the same deal for when we would shift, right? If I had like, right, if we had x minus 2 squared plus 4, how would you describe the shifting? Well, this would be up 4, right? Because that's just a vertical movement. And then this will be the opposite. So this would be right 2, right? So if I have sine of x plus 90, right, this is going to be left 90. Okay, so obviously notice this scale too that we're dealing with. Like very rarely, if ever, were you asked, like you would never graph a parabola like this. Usually, right? That'd be weird. And again, why is the scale here kind of different? Well, because for trig functions, right, when we look at the original sine and cosine, they exist between a cycle, one full cycle from 0 to 360 degrees. All right. So describe how the second equation changed. Well, we say it moved 90 to the left, right? This one is going to move 180 to the left. Okay, and again, if I wanted to, which again you can do on here, right? If I sine of x minus a, right? Add a slider. Oops. Oh, sorry. Right? And then I hit play. Right? What's happening? It's shifting. And then notice also, because my shift scale is only between -10 and 10, you don't really see a lot of it, right? But if I'd say -360 to 360, and then I hit play, now this is going to move a lot more. Okay? So that was fun. So again, here, phase shift, this is going to be 90 left. This one is going to be 90 right. This one is going to be 180 left. And this one, you got to be careful. If you remember when we graphed way back in the day, right? If I had something like, if I had like 2x plus 16, right? And some people would say, okay, this is going to go 16 to the left. But it's not, because what I got to do inside here is I got to have it factored. Okay? Oops, sorry. So same thing with the one we had here, 2x minus 90. Okay, that's what it was, right? Right? So here, what I have to do is I got to take out the 2. So again, this is still like the 2 is a horizontal compression by 2, right? And I know that means that the period of this one is 360 over 2, which is 180. But now my shift isn't 90, it's actually 45. So that's what we would put here, 45 right. Right? So hopefully that's cool. And then this one, same deal, vertical shifts up and down, right? That's going to be +2, that's going to be -1. So I literally take the whole graph and just move it. And again, if you like sliders, I can add a variable here, and then I can hit play, and then we can just watch what happens to the graph, right? And this is the same thing that would happen with like a quadratic or any other one, okay? So if we go here, if you look at the graph, again, +2 means up 2, -3 means down 3, and then sine x plus 100 means up 100, all right? Everybody cool with that? Okay, and then the next two are just, I mean, essentially your homework questions to make sure all this makes sense. So again, from a graph, can you tell me all this stuff? So like usually amplitude should be pretty easy, right? Amplitude here is 3. Period, again, like that's a 2. So I know that the period, right? The period is going to be 360 divided by 2, right? Which is 180. Phase shift, I get from this, right? So this is going to be 90 this way. And then the vertical one I get from here, right? So this is up 2. Okay? So hopefully that part was not too messed up. Let me see, will it stay there? Let me just get rid of this. I think it'll stay on my screen. Okay. So next one is given the graph on the left, complete the table below. So we want to figure out the amplitude, period, phase shift, and vertical shift. Okay, so here, now this one, I don't think I gave you the ability to sketch on here, so I apologize. I meant for this one to be able to be like sketched on, okay? So anyways, let's click on this one. So again, here, like in terms of like amplitude, like it doesn't really matter which one we look at, right? Like if we want to model using a sine or a cos, but like I know, so like if I look, okay, so here, so this line is going to be my max, right? I have a max at y is 5, right? And then here, right, this is a min at y is 1, okay? So what's halfway between 5 and 1, right? Well, you could say, you know, if I count, this is like, so 1 unit, 2 units, 3, 4. So that means like if I go from the min, if I go up to this line here is what we call the axis of the curve. So that's the line y equals 3, okay? So that means here, so like in terms of my amplitude, right? Well, what's my amplitude? It's gonna be like this distance from the axis of the curve to the max and from the axis of the curve to the min, okay? So what's the distance from 3 to 5? Well, that's 2. And the distance from 3 to 1 is also 2, all right? So hopefully that isn't too weird, right? Now, you can also click on the graph. So like if I want to model a sine here, like this is where sine is going to start. So check it out. Sine is starting at 45, right? So sine usually starts at 0. So I've shifted 45 in the positive direction, right? So that's what I'm going to write for my phase shift, right? So it's 45 this way. Now remember, the vertical, like this is the axis of the curve. This was on one of the notes that we talked about. So like this plus 3, or y equals 3, is what my vertical shift is. Because remember, the original sine starts at 0, right? And then goes up. So my vertical shift is just going to be 3. Now, what's the period? But again, the period may be difficult to see, but because you can click on the graph, you can say, well, okay, if sine, like this is 45, and then it goes up and down, and then it goes to 225, okay? So for my period, you'd be like, well, okay. Like what is the gap between 225? Oops, sorry, oh God. Sorry. Between 225 and 45, right? And that is going to be my period. Now, again, like where I do that, like I chose to start, like I started from here and then went to here, then went to here and went to here and went to here, right? So this whole distance, right, is 180 degrees, right? So the period of this function is 180. All right. I noticed also too, like you could have modeled it using like a cosine, like you could have done from here and go down, you know, like I just picked sine just because. So hopefully that is easy for you to understand if you had any questions from either question 1 or question 2. Okay, and that is it. So hopefully it makes sense. If not, again, shoot me an email, and then we will talk to you later. Bye.